We are up first. So, Mayan numeration. The Mayans used a decimal system which was counting on their fingers and toes. The Mayans used a base 20 system because you have 10 fingers and 10 toes. The Mayans' place values were 1, 20, 20 squared, and 20 cubed, and on and on. We think their number system is different than ours because they use dots and lines, and we use digits in powers of 10.
Example of a number. For example of a number, we have 433. The Mayans use expanded notation, so the first dot on the top would be 400, the dot under would be 20, and the rest would be 13. So you add them together, you get 433. For our multiplication problem, we did 8 times 10 equals 80, and it is shown next to the problem.
Mayan history / contributions. The Mayans were centered in Guatemala and extended out to Mexico. The Mayans actually made a calendar, and they made it by watching the movement of the sun go around and around. They even had jobs for that. The Mayans' calendar ended in 2012, but everybody thought they predicted the end of the world, and they didn't. The Mayans also built huge pyramids. They made 2 types of pyramids. Pyramids that were meant to be climbed and held sacrificial rituals, and pyramids that were not meant to be touched, and they believed they were sacred.
Inca numeration. The Incas used a tool called a quipu. The Incas had a base 10 number system. Each cluster of knots on the quipu is a digit. How to interpret the quipu? A simple knot represents any number that isn't in the ones position. A long knot represents any number from 2 to 9. A space where there should be a knot represents 0, and a figure 8 knot represents 1. Here we have 321 plus 123 is 444. So you would do 3 simple knots, 2 simple knots, and a figure 8 knot, plus 1 simple knot, 2 simple knots, and a long knot with 3 turns equals 4 simple knots, 4 simple knots, and a long knot with 4 turns.
The quipu means two knot or knot in Quechua. The quipu was used in the region of Asian South America. The quipu was used for keeping track of their money, records, and solving their math problems. The quipu was made of colored spun and plied hair from llama and alpaca hair because the animals were native to their land. The keeper. The person who holds the quipu is called a quipu keeper.
The office or house where the keeper lives is called quipu kamaya.
I'm just subbing for my classmate, Kate Briggs. She's not here right now. History of Egyptian numbers. The Egyptians created a number system to help keep track of time and stars. They used numbers for advanced problems and a system of taxes. The people of Egypt needed a way to add and subtract numbers.
The Egyptians can add, subtract, multiply, and divide. They could count to 1,000,000, and then the next number would be infinity. They used a base 10 system. So our problem is 85 times 5, and they used repeated addition. And we got 425, and this is a number. This is a problem in Egyptian.
Egyptians' contribution. The Egyptians had the idea of a calendar. The calendar consists of 12 months and 30 days. Euclid of Megara and Alexandria proved that prime numbers go on forever.
Greek mathematics history.
The Greeks made a number system to measure time and space. Their number symbols are based off their alphabetical symbols. The earliest proof of a Greek abacus dates back to the 5th century BC. A Greek abacus is a small slab of wood or marble.
Contributors in ancient Greece. Archimedes was one of the greatest mathematicians of his time. He invented
invented pulleys and the Archimedean screw-pumping device. Aristotle believed in the sun-centered universe, and Ptolemy proposed geocentric theory. Greek numeration. By putting a comma in front of any symbol in the front row, the Greeks could count up to any number to 10,000. The Greeks used a base 10 number system just like us, and the Greeks had no zero symbol in their number system.
This is our problem. 5 times 14 equals 70. In Greek, R is 5 and chi is an because there's no multiplication symbol. 14 is a triangle and 4 eyes because a triangle equals 10 and 1 eye equals 1. Equals, well, there's no equal symbol in Egyptian enumeration. Is 7 triangles, which is 70. Sorry. Practice your hard.
The Babylonian number system. The Babylonians used a number system because they used it to record amounts. They used it to design certain structures and buildings. They had a base 60 with a base 10 up to 60. They used a special wedge to make marks called the cuneiform. Now, their idea of zero was supposed to leave a blank space, which is why the tablets are not understandable. Here, there's 1 and 60. The 60 is more pushed to the left, and the 1 is in the middle. That's 10. The cuneiform is their alphabet.
That's one of the tablets. And the Babylonians created the 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day. They also created the 360-degree circle, among other things used daily. And they made a big contribution to mathematics today, which was their decision to make pi 3. And this is our example problem. 501 plus 364 equals 865. That's shown over there in the numerals. We couldn't really find any adding or equal signs, so we just did that.
The ancient Chinese number system. The ancient Chinese were supposed to memorize the 9 times 9 table. Long multiplication was similar to ours. They could write on bamboo rods, and they added left to right like us.
The ancient Chinese had no zero. To make a fraction, you would flip the numbers around, and to turn a positive number into a negative number, you would use this symbol. There we go. So this is a problem. Our way of our numbers, their way of their numbers, and their ways of our numbers. They use expanded notation. The system is about as hard as ours to use, and the only real problem happened with division, as they have not invented that yet.
The ancient Chinese could write on bamboo rods and tortoise shells to do their math and write numerals.
Emperor Qi Shi Huang, who was also the first emperor to unify China, ordered to burn almost all books not relating to his history in an attempt to make it so that people would forget the past emperors. In doing this, he accidentally made it so that we do not know why they made the number system. But we do know their number system. We don't know why they made it.
Liu Hu created the 9 chapters on mathematical art, which explain math. Zhu Shu created pi before the Greeks. The abacus, otherwise known as the style pen, was created in China, and there were many more contributions, and we cannot list them all.